Hello, and welcome to the new episode of Albert Einstein said, "If God has created the world, his primary worry was certainly not to make its understanding easy for us." Now, this quote is most certainly true when looking at the formation of the moon. But first, before we delve deep into the expansive knowledge the universe holds, we must travel back more than 100 years and discover how Einstein's brilliance came to be. Albert Einstein was born at Ulm in Württemberg, Germany on March 14, 1879. In 1896 he entered the Swiss Federal Polytechnic School in Zurich to be trained as a teacher in physics and mathematics. Unable to find a teaching post, he accepted a position as technical assistant in the Swiss Patent Office. During his stay at the Patent Office and in his spare time, he produced much of his remarkable work. He immigrated to America to take the position of Professor of Theoretical Physics at Princeton. He had a strategy of his own and was able to visualize the main stages on the way to his goal. He developed the general theory of relativity, one of the two pillars of modern physics alongside quantum mechanics, and is best known for his mass-energy equivalence formula, E equals mc squared, which has been dubbed the world's most famous equation. He received the 1921 Nobel Prize in Physics for his services to theoretical physics and especially for his discovery of the law of photoelectric effect.
Oh hey, didn't see you there. Carrying on, a true genius Einstein was. However, the real question is, how does Einstein and the moon link whatsoever? Is there a connection between the two? Funnily enough, in fact, there is. You know that quote that was shown earlier about how the universe is hard to understand and no one in this world really knows all the answers? Yeah, well, you see, even though the moon is our next door neighbour and has been for an astronomical amount of time, we still don't know anything about how it was formed. Absolute lunacy, am I right? But anyway, carrying on our quest.
The moon. No, not the prank teenage boys pull to have a laugh. I'm talking about the big wheel of cheese in the sky. Yeah, that moon. The one that has orbited the Earth for more than 4.5 billion years. Wow, 4.5 billion years. That certainly is a very long time. However, a question that haunts many people is, how in the world did a big chunk of rock land right there? How did it come to be? Where did it come from? Well, tune in people, because we're going on a journey. What a beautiful planet. Whoa, slow down. Where are we going? Wait, what's that I see? Off in the distance. Oh, hey there, little fella. All there by yourself? What are you doing all the way out here?
Now, it seems strange how a huge chunk of rock just came to be. This is why multiple theories on how the moon was formed have been debated for centuries. One, for example, was a theory that was previously thought to be true, which was dubbed the Fission theory. This theory was proposed by George Darwin, son of the famous biologist Charles Darwin, in the 1800s. He reasoned that the moon was formed back in the Earth's primitive stages of formation, where it was spinning rapidly around its axis. He deduced that because of the acceleration the Earth was under, a part of its mass was expelled. This mass then formed into the moon.
Here, it can be seen how the Earth's rotation forces it to expel mass, which leads to the formation of the moon. Now, of course, Darwin did not know how to prove that Earth was under such acceleration, as the technology wasn't available to do so. It was merely a train of thought.
You may be thinking, geez, this theory sounds pretty legit. Am I right? The logic in this theory was based off the fact that the Pacific Ocean represented the scar of this event, the huge mass of water covering 46% of the Earth's surface. It was proposed that the Pacific Basin was the origin of the moon. This seemed plausible as the moon's composition resembled that of the Earth's mantle. The elements found in the moon rocks were known as siderophiles. Siderophiles are high-density transition metals, also known as precious metals such as gold, platinum, and iron. The fission theory provides an explanation on how these elements are on the moon as well as its iron core. This theory seems very plausible, right? Well, you're wrong. Through the accomplishments of the Apollo missions run by NASA and the moon rocks gathered, the moon was deemed 4.5 billion years old, compared to the Pacific Ocean's age of just 200 million years. Therefore, it can be concluded that the moon did not originate from the Pacific Ocean, deeming the fission theory obsolete. What's more is that if the moon was expelled from what is now known as the Pacific Ocean, it should be rotating around the equator of the Earth, which is not the case.
Now this is where the new, most accepted theory comes into play. The giant impact theory is the most accepted theory among scientists today. It theorizes that a Mars-sized-like planet, dubbed Theia, 4.5 billion years ago, drifted into the path of Earth on a cataclysmic collision course. It hit the Earth with a glancing blow. Imagine the immense power released from this collision. It's unfathomable. The result forced molten rock into space. The rock coalesced into one, which formed into the moon.
In 1946, a man named Reginald Aldworth Daly of Harvard University challenged Darwin's theory, postulating that the creation of the moon was caused by an impact rather than centrifugal forces. Little attention was paid to Professor Daly's theory until 1974. The idea was published in the book Icarus in 1975 by doctors William Hartmann and Donald Davis. Their models suggested that at the end of planetary formation in our solar system, several satellite-sized planets had formed that could have possibly collided with other planets. Therefore, it was theorized one of these bodies could have collided with Earth, ejecting mass. This would then explain the moon's composition according to moon rock samples gathered by NASA. Buzz Aldrin was the second man on the moon, Neil before him, and they began a critical point in space aviation: the space race. Now, these missions led to an abundance of moon rock samples for scientists to analyse. Now, up until recent years, this theory has been nothing but people's thoughts, calculations and conjectures. There was no hard proof. The four leading scientists on the moon, William Hartmann, Donald Davis, Alfred Cameron and William Ward, still couldn't come up with a definitive explanation on the giant impact theory. However, in recent years, more light is being shed on how the moon was formed through computer simulations. Through various computer simulations by Alfred Cameron, it is now theorized that the giant impact theory was not just one huge collision, but in fact two. From his simulations, it indicates that Theia not only rebounded off Earth, but it kept in suborbital flight around it and crashed into it again. Theia's core was consumed by Earth while its remnants were cast off into orbit, eventuating into the formation of the Moon. However, it should be noted that Cameron himself believed that there are still several parameters to test. Fellow scientist Josh Melosh of University of Arizona points out that the physical properties called the equations of state he, Cameron and others use in the impact simulations is far from perfect and might lead to unrealistic results. Cameron agreed, noting that he considers this game very primitive so far. What's more, is in 2012 another research team used lunar rocks rather than models like Cameron. The team analysed 20 samples of lunar rocks, including ones brought back from the Apollo 11, 12, 15 and 17 missions. They found that the lunar rocks have much lower concentrations of zinc, but are rich in heavy isotopes of zinc. If you don't understand what an isotope is, it's a variant of an element that has a slightly different mass. Basically, this means an atom with more or less neutrons, so the element stays the same, but the weight differs from the original element. A good example of this is carbon-12, which is the element of carbon, and carbon-14, which is the isotope as it has more neutrons, making it heavier. Moynier, the lead researcher, stated that isotope fractionation must occur for the giant impact theory to still be viable. Isotope fractionation is when a rock is melted, then evaporated. The light isotopes enter the vapor phase faster than the heavier isotopes, leaving a vapor enriched in the light isotopes and a solid residue enriched in heavier isotopes. Now, when scientists first tested this years ago, the results were inconclusive. However, Moynier was hell-bent on finding an answer. He discovered that the isotopic homogeneity of the moon rock did in fact have fractionations, and this fractionation resulted from a large process. The team concluded that the most likely large-scale event was a huge collision that resulted in the molten formation of the moon. The zinc isotopic data supports the theory that a giant impact gave rise to the Earth-Moon system.
Although this cannot confirm how the moon was formed, it is a great leap forward in understanding how it came to be. There is still a huge amount of work to be done if we are ever to find the answer. Now, before I leave you to ponder on the information I have given you, I'm sure you're nagging to know, how can we truly know how the moon was formed? Well, as you can tell, we're getting closer. Each theory better and more precise than the other. But there's a limit to what we humans can understand, some more than others, but no one with the knowledge to know everything. The only way I can see us ever finding out how the moon originated is with better computer simulations or further tests. But then again, how many tests can you do? I mean, we've basically done them all already. Will funding help? Sure, why not? But is it really worth it? Spending money on finding out how the moon was formed sounds interesting. But again, is it really worth it? Should we just be content with what we know and the fact we will probably never find out? Or should we push for greater understanding? If we pushed for greater understanding, would we only end up losing it on the way? That is a risk a scientist must take. For me personally, throughout the journey I've taken with you, I've come to understand that maybe it doesn't matter how the moon formed, as long as we have it and marvel at its creation. whether we know it or not. It seems that after all this, we still really don't know that much about the moon. It may be that we'll never know how the moon originated, and if we ever do, it probably won't be in the near future. It seems like Einstein really did know what he was talking about with his quote, "If God has created the world, his primary worry was certainly not to make its understanding easy for us." After explaining the fission theory by Charles Darwin and how that was disproved, along with the giant impact theory, which has caused debate since the 1970s, it seems very clear that God did not make this universe easy for us humans to understand. But then again, can we understand God at all? Or the fact that we may not be the only universe out there? I guess that's another issue for another time.